everyone aware of what is meant by vacuum tube device? Okay, vacuum tube is nothing but what some hollow gap will be there in that device. The best example is the microwave oven. Okay, how the oven device will be there, one door will be there open, and inside you have one cavity. Inside that only we will keep the object for heating, and we will heat. Okay, so that is the main functionality. So how it comes? Okay, let me start with some active devices like diode. So the diode, actually you have studied into the basic electronics. I told about the diode is act as the switching device. Okay, basically act as the switching device, where this microwave tube act as both oscillator and amplifier. So can anyone tell what is the purpose of oscillator? Oscillator, okay, I itself tell oscillator is the one which produce the output without any input. Okay, so due to some potential applied to the oscillating device, so we no need to provide any other inputs to the oscillator. Okay, that itself produce some output with good amplification. So what only this device is called as oscillator and also amplifier. So it will act as both oscillator and amplifier. Okay, so this introductions we have studied in the last class. So this is the schematic diagram of the two cavity klystron. Please see two eye symbols are there. So it will be look like mm, two eyes, and in separate you can see the terminals of potentials are there. Okay. How come it acceleration and deceleration has been taken place? I told in last class with the help of this video. Okay. So anyway, I will share one video related to this topic. Can you able to see my video content? I'm not played right now. Can you able to see the klystron?
Yes, sir.
Yeah, yeah. I will play this thing. So just I will show the how this mechanism works. So you can see this. This is the setup of the klystron. Okay, so you should know how what is the picturization of the klystron. So every time we are reading the textbook and some block diagrams are there. Like this only the klystrons will be there. Please see here. This is one cavity. This is another cavity. This is another cavity. This is another cavity. So totally here four cavities are there. Okay. In real, we going for multi-cavity klystron. But as per our syllabus, we having only two cavity. One cavity will act as the buncher cavity. Another cavity will act as the catcher cavity. So buncher is the one which generates the electron, where catcher cavity which accepts the electron. Okay. So here the first one will act as the buncher. The all other will act as the catcher only, but the thing is that effective catcher will be the last one only. Why means whatever buncher cavity electron, first buncher cavity produce electron, that will be again accumulated here only. It will be catches, and it will when it regenerates, it will multiply and send it to the another one. And again here also it will catch, and it will multiply and it sent to the last cavity. So like this only this process will be goes. So you can ask why this grouping of electron has been taken place in this device. So once the electron one thing I have to tell, the majority carrier of the electron is the that is sorry that is majority carrier of the negative polarity is the electron. For positive p type is the hole. Okay, so based on the biasing, okay, based on the biasing, so this klystron will be taken place. Just to look into how the clustering process, sorry, how the acceleration and deacceleration process has been taken place in this device. So here there is no audio, just to show the mechanism. So this is just two cavity klystron only here they have shown. That is the real time. Okay, in real time there are multi cavities are there. So please see. So one side will be a positive plate, another side will be a negative plate. So one side has the buncher cavity, another side has the catcher cavity. Please look into this thing. So this yellow color beam is nothing but the beam of electron is going from the starting point to the catcher point. So once it goes, we see this is one side is the positively charged, and another one is a negatively charged. The electron will starts to move within this gap of the first cavity. Once it goes, please see at the bridging orange color part. Okay, so there only the accumulation of the electron has been taken place. So at a certain interval, all electron will be catched by the catcher cavity. Okay, that is a catcher, the V shape. Okay, you can see one terminal like this. This is your catcher, where this entire setup is called a catcher cavity. So at top, we are providing the RF input. Okay, RF input. So RF input is a radio frequency signal. Okay, radio frequency signal we are lively giving to this unit venture cavity. Please see how the beam is evolving. So once the beam radiation comes to the buncher cavity, this electron comes from this input side has been bunched together. Please see in between you can see some clustering of the electron. It has been bunched, and when it goes to the catcher cavity, some heavy radiation of signal has been taken place. The beam is going. So from the outlet, you will get the amplified signal. Suppose my input is around some what 10 volt. I will get output at least 10 minimum. That is above 10 volt only. I will get. Okay, above 10 volt only. I will get. So you can see how the cavity will be. Some hollow gap will be there inside. So this is the design setup they are showing here. So in this opening of cavity only, the electron will be passed and it will be induced on the surface of the material. Be positively polarized, another plate will be polarized with a negative. Okay, so for negatively charged, electron will be the majority carrier. For positively charged, volts is the majority carrier. So mostly this type of device works with the reverse bias condition. Okay, at forward bias condition, minimum conduction has been taken place. For reverse bias condition, the maximum effect will be taken place. Please see how the acceleration has been taken place. Before the arrow mark is below, now it has been upward. So accordingly, it will be accelerate and deaccelerate. Please see here. The polarity also changes. Please see how the effect of this thing has been taken place. We are talking about acceleration and deacceleration. So just I will tell one best example of the acceleration and deacceleration. So when the car is moving around some 100 kilometer per hour, okay, 100 kilometer per hour. Okay, so then the wheel goes in forward direction. Okay, so the rate of speed also very high, the car. When we slow down, what happens? We just braking our system so that the wheels will go in opposite direction, so that it will get slow down. Okay, the rate of speed will be get slow down. So that is the main mechanism of the automobile. Similarly, here also, once goes in clockwise direction, the rate of speed of electrons moves very fast, and it will radiate the heavy energy. If it is deaccelerate, then rate of speed of electron, okay, it's reduced, and then the radiation also we will get a minimized. Okay, so this is the mechanism will cyclically occur for each and every unit. So there is another unit also there, catcher cavity. So the same mechanism will goes. Okay, once the electron goes in this bridge unit, and after please see how it goes, how it collected at the catcher cavity. It is will be clustered or bombarded. All electrons will be bombarded with each other, and it will be tends to move forward direction. And at the catcher cavity, once it touch, and some electron may be returned back. Some electron will be catched. Most of the electron will be catched. Only few electron will be get returned back. Okay, so this is the whole mechanism will be happen. Yeah, so please see, this is the called as the modes of operation we will tell in the reflex klystron amplifier and oscillator. Please see, at zero mode your amplification will be high. When it goes with the subsidiary point like 1 2 3, okay, then it will be like an impulse signal. Okay, so at a zero, okay, you will get the maximum amplification. When it goes to 1 2 3 up to n, the modes, different number of modes, the amplification of your signal will get down. So this is the whole mechanism of your uh, klystron amplifier. Okay, so this one only we have seen. So in this there is a two types I told. One is a O type and another one is M type. So the which I have shown is the O type microwave tube. So the O type microwave tube is also called as the linear beam. So this will works under the principle of two modulation scheme. One is the velocity modulation, another one is density modulation. So the density modulation is also called as the current modulation. Okay, so the example is klystron and TWT. TWT is a traveling wave tube antenna. Okay. So another thing I have to point out and remember, in last class itself I told the moment of electron and the stable position of electron. In moment of electron, the existence of magnetic field occur, and in stable position of electron, existence of electric field occur. So you just to keep it in your mind whenever we are using any active device or passive, mostly the active device. Okay. So once we apply the potential, as an engineer, someone will ask that whether electric field and magnetic field occur in that device or not. Yes, exactly. It will produce the electric field and magnetic field, where electric and magnetic field are transverse with each other, which which works under the principle of Fleming's right hand rule. Okay, so maybe in physics you have studied. Another one is called as the M-type device. In M-type device, the magnetic field is perpendicular to the electric field, where the field will be like a circular manner. Example is cyclotron and magnetron. Okay, so let me go with the two cavity klystron amplifier. So this one also I have explained, and specification also explained in last class. Let me go with the, yeah, some technical terms like drift space. What is the drift space? The drift space is nothing but the separation between the buncher and the catcher. So the buncher, which one is the buncher grid? This one is the buncher grid. Where catcher one is this one. Okay, so the space between this is nothing but the drift space. Okay, so and please see all electrons injected from cathode drive at the first cavity with uniform velocity. What it says, once you apply the polar potential, the switch, okay, the electron will be start move from the cathode drive, and it will move toward with a uniform speed. Okay, technically called as uniform velocity. The second point, please see the electrons beam through first cavity gap at zero of the gap, voltage Vg is equal to zero, passes through the unchanged velocity. The same meaning of this thing, okay, as I told before. The electron beam radio frequency of gap voltage undergo an increase in velocity. Okay. The fourth point is electron beam passing through negative half cycle of the gap or gap voltage undergo and decrease in velocity. Okay, as I told before. Okay, so one is acceleration and deceleration based on the polarity change on the top and bottom. As a result of these action, the electron gradually bunch together as they travel down the drift space. So I shown the picture also. The electron is moved toward that gap only, and it passes through that bridge unit between the buncher and the catcher. Through the drift space only, it is moving. Okay, so with a uniform velocity. So that is called as the velocity modulation. The variation of the electron in drift space is called as the velocity modulation. So velocity modulation sometimes increases or decreases also. Sometimes I will ask one small scenario. One big person is there and one small person is there. Both of them are pushing with each other. So who will wins? That is whether the big person or the small person. So you itself imagine the two persons are standing opposite to each other. Okay. So when they push each other, who wins? Exactly, the big person will pushes the small person easily due to weight and height. Okay, so he will definitely move past the other. So like that, here some big electrons will be there, some moderate size electrons will be there, and small size electron will be there. When bombarded with each other, okay, due to the density of electron, the smaller electron will tends to move. But the smaller electron will not able to bump. It will bombard, but it cannot push the big one into the forward direction. Again, it will come to the reverse thing. Okay, so velocity modulation process sometimes continues to increase the density of electron into the second cavity. The second cavity is exist by AC signal impressed on the beam in the form of velocity modulation with the resultant production of an AC current. Okay, so why I'm reading is that as at least once, whatever mechanism I told, technically you should know these points. Okay, these are the points is very important when you are preparing for. If you see in the textbook, it is very huge and it is unnecessary points also there. So the some important points alone I have noted based on the mechanism. The AC circuit on the beam is such that the level of excitation of second cavity is much greater than in the buncher cavity, and hence amplification takes place. So what I told, so when the electron is injecting toward the buncher cavity, what happen? It will be for flow to the next cavity, that is catcher cavity. So once it will catch maximum number of electron, it will get amplified. It will be bunch all the electron together and it will get amplified. Okay. So if desired, A portion of amplified output can feed back to the buncher cavity in regenerative manner to obtain oscillation. Already I told in the catcher cavity or catcher metal, once the electron will strike, some few electron will send back. Okay, some few electron, not maximum number of electron, few electron will come back. So that may produce for regeneration and it obtains the oscillation. Okay, so only due to the electron only this amplification process and oscillation process has been occurred. The maximum bunching should occur approximately at the midway between two cavity during the retarding phase. Okay, so at the deceleration, when the deceleration has been taken place, the polarity changes again, negative to positive. So first is the positive to negative. Again, it changes to negative to positive. At that time, some retardation has been taken place. Retardation is nothing but just breaking or reducing or delaying. That is the typical meaning of the word called as retarding. So it will get retard or deaccelerate at the mid or the bridging unit of the two cavities. Thus, the kinetic energy is transferred from the electron to the field in the second cavity. So most of the kinetic energies will be transferred to that electron in the second cavity. So the electrons then emerge from the second cavity with reduced velocity and terminate at the collector. As I told, some few electrons only return back. So when it return back, it will goes with the less velocity only. But again, it will be regenerate and it will collected at the collector only. Okay. So thus the output cavity catches the energy from the bunched electron beam. So that is called as the catcher cavity. So like this only the process will be taken place for the reflex klystron amplifier. So similarly for oscillator also be the same. Okay. So there is a two different topics in your syllabus. One is a two cavity klystron and another one is the reflex klystron oscillator. Okay, so this type of devices where it can be done. So I will show one more video to you. So it will be know how this mechanism works. So can you able to see my YouTube? Can you able to see the YouTube screen, YouTube browser? Can you quickly respond? We will play this thing and go ahead with the last topic of the today's. Can you able to see this thing, YouTube browser? Students, quickly please respond. David Samuel,
Yes,
can
sir.
you able to see? Yeah, yeah, thank you.
Yes, sir.
So I will quickly, yeah, thank you, Lakshmi Sudha. I will quickly play this thing. This is the day to day we are using this device. Just look this animated thing. I think audio is coming or not, I don't know, but no need of audio. So you should know what is the microwave gadget inside the microwave oven. So it contains the active device only. So this device is called as the magnetron. So please see they have shown in dismantled how it has been assembled. Please see the filament is glowing very high intense due to the cluster of electron. How the biasing has been taken place? Where blue lines are nothing but the flux lines. So most of the mechanism will be like this. It is nothing but the circulation of the field. So we have seen two type of device. One is O type and another one is M type. So this is M type. So this device also we will study in the next part. So please see how the radiation of the heat is going inside to the food items. So please see once the radiation goes inside, how the molecular changes has been changes. Accordingly, the food has been get boiled. Mostly in our laboratory, we are using X band of frequency. So that's all. The food has been cooked and boiled, so it is ready for eat. Okay. So this is the mechanism of real, that is real microwave device. Okay. So instead of telling the full theory, it is boring for you also. Okay, just I have picturized how it will be work, so that it will be while you reading the content, it will be very useful. So the application where and all can be used. It can be used for satellite communication and VHF TV transmitter, radar transmitters. So here and all they will apply. Okay. So this is the first topic in your second module. Okay, so there you can have some characterization um, graphs also there. Okay, so in last class I have explained with help of some slow electron, a moderate electron, and a fast electron. So how the acceleration and deceleration has been taken place. So acceleration means what? Acceleration I will tell in this graph. Please see, x-axis is your time and y-axis is your potential, applied potential. So you can, I will put it in different color. Okay, so acceleration, I will put it in green color. Okay, so I will. Okay, so I will put green color as acceleration and a red color as a deceleration. Okay, red color as a deceleration. Please see, with the help of this, I will explain you. When at 0, please see, this is your time scale. Okay, this is your time scale. This is your applied potential. Okay, this is your applied voltage simply. So once I switch on, what happened at a time t is equal to 0? At time t is equal to 0, there is no amplification has been taken place. This is your positive half cycle, this is your negative half cycle. So like that, cyclically it will changes. So please see, it will tends to move in this direction. Okay, like this it is forwarding with a constant rate. constant rate. Once, suppose this is the point at the catcher cavity. At catcher cavity, what is your intensity level of your electron? It is very high. Why? All electrons has been at this unit only. So what only we getting the RF energy or RF signal. Okay. So it is collected at this point. So once it is touch on that catcher cavity or catcher metal, it will get deaccelerate. It will comes down. Okay, it will be deaccelerate. So sorry, draw neatly. It will be deaccelerate. It will be like deaccelerate means slow down the rate of process. It will be like this, so that our speed will be get reduced. So what happened? It will be speed up. It will be speed down. Speed up, speed down, speed up, speed down. Like this only, this oscillation process has been taken place in this unit. Okay, so this is the characteristic graph. Okay, just to know, this is the Applegate diagram for the reflex klystron. So this is the mode. As I told, this is the mode. There is three modes will be there. So once the number of modes increases, accordingly, the amplification of your electrons has been taken place. Okay, so this is your bunching distance. You can see one is at the slower electron, another one is moderate or same, another one is the faster electron. So the slower electron, please see the slower electron at the negative half cycle. Okay, at negative half cycle, okay, this is the negative half cycle. What is the respective time? This is the slower electron transit time. Okay, so this T denotes normally not time. It is called as transit time. Okay, similarly the moderate, please see, and fast. But at last where it meets, it at the buncher cavity only. So bunching center is nothing but your the between your bunching cavity and the catcher cavity. Some bridge unit is there. Here is the meeting point of all three electron, and after that, that electron will be catched by the catcher cavity. Okay, so this diagram represents that one. So this is the mode. Please see the mode. The first mode. Okay, so the first mode, the operating actually it will go comes like this in a reverse order. Okay, in a reverse order. This is your first mode. This is your second mode. This is your third. Please see the operating frequency is small here, but amplification please see higher. Here, somewhat gradually operating speed, operating frequency is higher. The magnitude is comes slow, or it is comes down. You can see third mode, again the amplitude becomes less, but operating frequencies. It is works under the concept of lambda is equal to C by F. So lambda is your wavelength and F is your frequency, C is your velocity of light. So if